Volume and surface area questions can be a little tricky, and this one is actually asking you to measure surface area and a sort of volume and take it one step further and calculate weight. Look at what's being asked here. We're told we have this giant rocket, which is, for our purpose, just a cylinder, right? It's got a width, right? 9 meters wide, 72 meters tall. So we're asked to figure out how much paint is going to cover this thing. And it's getting painted on the sides, right? Not the top, not the bottom, just the sides of the cylinder. Okay, so I've got an equation here that tells you how to find the surface area of a cylinder, the curvy part of the cylinder, not the flat top and bottom parts. And what you do is you take the circumference and then you multiply it by the length. Okay, now to give you an idea of what's happening in the picture, it's like you're taking the length of that circumference and then going upwards, directing that upwards. So this length of the circle turns into an area of the side of that cylinder as you project it across that dimension. Okay, so what does that actually mean? Well, we take this formula and say, okay, fine, pi times diameter, which is 9.3, times length, which is 72.4. Okay, not too bad. And according to a helpful calculator, that is going to be pi times 9.3 times 72.4, which is kind of big, 2,115, I'm going to say 0.3. We've got to round it somewhere. So we're going to say 2,115.3, and the units on this will be square meters, because we did multiply meters by meters, so that's going to be square meters. Now, what's volume? And remember, I'm not talking about volume of the cylinder. I'm talking about volume of the paint, because if we're going to measure how much weight is added because of the paint, then I need to know how much paint there is, right? Which means right here, layer of paint right here, layer of paint right here, and paint right here, and paint right here, and I realize that it has a teeny little thickness to it, but very skinny paint, but it does have a thickness, so that's going to have a volume. And the way you calculate volume of paint is you take the surface area, which we've already figured out, that's 2,115.3, and you multiply it by the thickness of the paint. Well, we were told the thickness of the paint, that's 0.27 millimeters. Okay, that's interesting. How many meters is a millimeter? You're going to have to take that 0.27 and divide it by 1,000. Because if you did 0.27 times the surface area, what you're saying is this thing is like a foot thick paint. And that's not what's going on, right? It's 0.27 millimeters, not 0.27 meters. So this is the way we do that multiplication. And I'm going to do 0.27, oops, I did 0.24, divided by my thousands, that's important, which gets me a volume of 0.571, not in square meters anymore, that's cubic meters, because I multiplied by another dimension, cubic meters. And now the last part, what's the mass of that paint? How much does it weigh? Well, you take its density, which is given to you, that's 1,500 kilograms per cubic meter, which I'll write this way, that's the physics way of writing this, times the volume. Well, what's the volume? That's 0.571 cubic meters. So now we punch this into our calculators. 1,500. 856 kilograms. Okay, this is a tough problem. This is kind of sort of bridging into a little bit of a physics sciencey question. And what you have to do is think of these three formulas, all of which you should know. You should know the surface area of a cylinder. You should know how to figure out the volume of a very thin paint layer. Just take that surface area and multiply it by T, the thickness. And you should know how to go from mass and density and volume and how to relate those two in an equation for weight right there.